Let's examine a simple and familiar concept, the concept of divisors. Suppose I have number 24. What would be the divisors? There they are. What if I have a prime number? Then I would have two divisors. That's what the prime numbers are. And what if I have something like 32, which is power of 2? Then you would have all the powers of 2 showing up. So if I have a 1024, you would have all the powers of 2 coming out as their divisors. Another name for the divisors is the factors. So they are the same concept. Okay, now what do we do with this? I want to examine the divisors from numbers 1 through 100. So we are going to find divisors. Of course, I'm not going to enter 1 through 100. I will just find the divisor of I. Then I will make the I go from 1 through 100. Okay, and then I will make a table out of it. There we go. There they are. Now, so these are the divisors of each number, but actually I'm more interested in the number of divisors, how many they have. So instead of finding divisors, I will find how many elements that list has. So I will find the length of the list. So if I do this here, it would tell me how many you have. There we go. It has 11. So I will do the same here. I will find the table. Oh, no, I meant length of the divisors. There. And these are the length of the divisors. Okay. I'd like to see them in a more appealing way. So I will assign this to a variable called result. And then I will plot the result. So of course I can list plot. But that doesn't look right. It's hard to see the pattern in it. You could list line plot, but still it's kind of confusing and it's misleading because between number 1 and 2, for example, you don't have this value in between. That is, you should not connect them because there's nothing in between happening. In other words, no numbers have 1.5 divisors. So what you should do is not list line plot here. You should do bar chart. That way it doesn't connect to each other. It tells you exactly how it is. Okay, so that's what we get. But I want to see this in a more appealing way, so I could do array plot of it, of result. And this is what I get. But this is rejecting me because I have only one row of data. Array plot is used to having arrays. So I have to say, yes, this is an array with just one line. And that way it will accept. I meant array plot. There we go. So that's what it is. But this is somewhat confusing because you would expect the higher number to have brighter color, but it's the opposite. So we can change the color function to so that it reflects exactly as it is. So dark means you have few divisors, and bright means you got many divisors. Okay, so this is what we can do. Is there anything else we could do? Yes, we could see this 100 of them in 2 by 2. I mean 10 by 10 in two-dimensional form. That is, I will change this here. And instead of finding divisor of I will go from 1 through 10, and I would let j go from 1 through 10, so that I get 10 by 10 box, 10 by 10 matrix. But how would you write this in it? Well, you will have numbers that are going from, let me show you. You will have a box like that, right? That first row would be 1 through 10, and the second row would be 11 through 220, then 21 through 30. So you see, the very first number, 0, 1, 11, 21, the first number is I. So I should start from 0 to 9, because the last one will be 91 through 100. And j is the last number, last digit. So if I have, say, 56 in the middle here, 5 came from I, 6 came from j. How do you turn 5 and 6 into 56? You have to do 5 times 10 plus 6 would give you 56. So what I will do is I will let I go from 0 to 9. And then here I will say is a 10i plus j. That way, this will manufacture number through from 1 through 100 in a two-dimensional way. You will see here. Shall we call this result 2 in 2 dimension? So this is what it looks like. Let me show you better. Result 2. This is what it looks like. So now this plotting would make more sense here. So I will just steal this line and plot result 2. Okay, I don't need this time because it is already 2 dimension here. So there we go. So this is what I get. Very nice. Now we can see who has more divisors. These have lots of divisors, and black ones have very few. But you want to see who the prime is. As you know, prime has 2 divisors only. So we will pick them out. How are we going to pick them out? We will use color rules. So if it's a two divisors, okay, and then we say we want it to be, what color do you want to make it stand out? Blue? Okay. I meant to do arrow here. Okay, so that's my color rule. So here we go. So blues are the prime numbers, and the rest are telling you how many divisors they have. The lighter one has more, and darker one has fewer. Okay, now, shall we get greedy? Now, we should do 100 by 100 now. 99, this would be 100, and this would be 100. As simple as that. So let's run it. We got that. If you want to see it, we got too big, but let me show you a little bit. Here we go. So we got 100 numbers each. It's overflowing. So that's what they are. It's just too much to see with our eyes. So we'll graph them in array plot. So we'll do Shift Enter. There we go. That's how it is. Okay, so you are able to visualize where the prime numbers are scattered. You can see an interesting diagonal number for the prime numbers. And you can see there's white dots here. No, I meant, sorry, the blue ones are the prime numbers. So blue ones are scattered all over. You would think you would get fewer and fewer of them as you go to a bigger number, but still, it seems to be quite busy. Although we are looking at 10,000 numbers here, it is still quite busy. Here, I'd like to change the grayscale from gray level to solar colors. Okay. And there we go. So that's what it looks like. For now, let me suspend this prime numbers just to show you here. So this is what it looks like. So number across here are having a lot of divisors. But you can see here, although as you go to the bigger number, they have more and more divisors. You can tell it's getting somewhat brighter toward here than here. But it's not by that much. And as for where the prime numbers are, let's find them again. But this time, instead of blue, I will use white to make it stand out even more. So let's see where the prime numbers are. I forgot the comma. Here we go. You would think there will be fewer and fewer prime numbers, and it's true. You will get fewer and fewer numbers, but not in this range. It's pretty much, you would feel this is more or less evenly distributed white dots, right? It seems that way. Okay, now let's see if we can explore some more. Let me delete this one. So this time we are going to do 1,000 by 1,000. So it's a 999, 1,000, and 1,000. And I am not going to see the output. So suppress the output. Then array plot. So now we are going to look at 1 million numbers, and you're looking at it. So these are, first let me show you without this prime numbers. It's somewhat throwing us off in terms of perception here. First, let me show you without it, and you have the solar scale here. So these are the numbers. Let me see if I can expand this even further. Okay, so you can see the numbers running down here has a lot of divisors. And as you can see in the pictures, you can do this yourself to find out. So there's an interesting pattern emerging on who has larger number of divisors. Okay, now let me bring back the prime numbers here. So let me bring back the prime numbers. So here we go. So once again, the white dots are the prime numbers here. And prime numbers, they don't seem to get any fewer, you see. Although we are looking at full 1 million of them. Let me slide this window to the left here. So all the way down to 1 million here, you seem to have just about the same number of prime numbers from beginning to the end. As you can see, when it's represented this way, you can see that we got lots of prime numbers, and intuitively, it feels that we would not run out of them. Okay, so this is one way too. Now, the reason I did this is to show you that even something that is linear, such as number of divisors, and we have this contiguous number going 1 through 1 million, you are able to represent it as 2D by using this technique. So this would apply to many applications when you want to find a pattern. And this doesn't even have to be in clean numbers like thousands or by hundreds. You could make this with arbitrary so that you can see more patterns emerging. And in fact, my next e-learning is on that, so please watch it to learn how you can arbitrarily control the column numbers so that you can see more interesting patterns emerging from there.